Railway-oriented programming is a functional approach to designing your applications. Functions can either succeed or fail, and this is represented with a respective result object. I'm going to show you how to refactor from an imperative style of coding to a functional one using railway-oriented programming, and we're going to discuss how to handle side effects in this environment. I have a use case here for sending an invitation to a member to a certain gathering. This is written with a typical imperative style of coding. We first fetch the member and then the gathering based on the command information. We do some null checks. Then we execute the actual business logic, which returns a result containing an invitation object. If this is a failure, we return. And lastly, if we succeed, then we want to add this invitation to the repository, save it in the database, and also trigger a side effect of sending an invitation email to the member for this gathering. Before I show you how to refactor this to use railway-oriented programming, let me briefly show you what that actually looks like. I'm going to head over to the email value object, and in the create method here, I'm applying railway-oriented programming. So I'm taking the email string and I'm calling result ensure to trigger a set of validations, and the end result of this is I get back a result of string object. So this is the first step in my railway, and then the next step is executing a map function. And why this is interesting is the map is only going to execute if the previous result object is successful. Otherwise, if it's false, it's not going to execute the mapping function. It's just going to propagate the existing error and return a new failure result. In order to apply this on our command handler, I need to make a few adjustments. So instead of inheriting from iRequestHandler from mediator, I'm going to inherit from iCommandHandler, which is defined in my application. And this is just an interface already inheriting request handler, with the difference that the return type has to be a result object. Of course, I'm also going to need to update my send invitation command to be an iCommand, which is also defined in my application. And iCommand is nothing than an implementation of iRequest of result. So I'm enforcing my application to always return a result object, which is going to help me tremendously in implementing railway-oriented programming. With our command and command handler in place, we just need to adjust this here to be returning a result object, and then I need to update the return values of my handle method. Instead of returning unit value here, I need to return a result instance. So I'm going to say return result failure, and I'm not going to be very specific here, and I'm just going to return an error null value. Here I can do something interesting because I already have an invitation result. I can say return result failure, and I can use the existing errors on the invitation result to propagate this up to the caller. And lastly, I'm just going to say return result success. And now my handle method is always returning a result instance. So now let's talk about refactoring this into a railway-oriented approach. The first thing I need to do is to convert my member and gathering objects into result objects. So how I can do this is I can say result create, and I can pass it the value that I want to convert into a result object. So now instead of having a nullable member, I have a result of member. I'm going to replace this with var just to make things easier, and I'll rename this to a member result. Let's also do the same for our gathering. So I'm going to call result create and create a gathering result here. So I'm going to say var gathering result. Awesome. If you're wondering what a result is, it's a simple class with a failure and a success flag, an array of errors, and a bunch of static methods to help out with designing a fluent interface. So what I need in my command handler is a way to combine these two results into a single one. In my result class, I already have a combine method. The problem is it only takes in a single type and returns a combined result of all of these types. So what I actually need is something similar to this. So let's say I want to return a result, but I want it to be a tuple containing two types. I'm going to call this method combine, and we're going to give it two generic arguments. where each one of them is going to match one result instance. So I'm going to say result of T1, I will call this result 1, and then we'll have a result of T2, I will call it result T2. And now I just want to combine these into a single result instance and return a combining result containing the tuple of the two values. So I'm going to say if the first result is a failure, then return a failure of T1, T2, so I need to match on the return type, and I'm going to pass it the errors on the first result instance, and I'll repeat the same for the second result instance. So if we have a failure in either of the two result objects, then we're going to return a resulting failure object. Otherwise, we can say return success, and we're going to take the two values, so result 1 value and result 2 value, we're going to map them into a tuple and return them in a new result object. So now in my command handler, I can say result combine, and I want to combine my two results that I have here. I'm going to take the gathering result first, and we're going to pass that as the first argument, and then let's pass in the member result as the second argument. And now I can get rid of these two variables. And now I no longer need to do this null check here, because it's going to be taken care of by the create method, which will return a failure result if the value passed in is null. So let's get rid of this. So what does result combine return? It returns a result containing a tuple with a gathering and a member instance. If this returns a success result, then we have both of our values, and we can continue with the next step in our method. The next step is going to be how do we invoke the send invitation method on the gathering instance. So we need to call the bind function, which I already have defined in my result extensions. I'm interested in this overload here, which gives me access to the tuple containing the gathering and the member, and I can return some other result type in the bind function. I can't use the construction, and I'll have to use the tuple directly, but the first item on this tuple is the gathering, and I can call the send invitation method and pass it the second item on the tuple, which is a member. Now if I take a look at my bind method, I'm getting back an invitation result, which is what we had here. Now I can get rid of this check here with checks for a failure result, because it's always going to be handled in my extension methods working with the result objects. So let's get rid of it here and move on to the next step, which is adding the invitation to the repository. This kind of method, which doesn't return any value, is a side effect. And the side effect of this call is the invitation being added to the repository. In functional programming, a function like this is called T or tap. I'm going to create an extension method on the result object that's going to allow me to execute this type of function. So I'm going to call it tap because I'm more familiar with that kind of naming. And this isn't an asynchronous method, so it's just going to return a result of whatever was the input result. I'm going to call it tap and add the generic argument, and it's an extension method on this result object. What I want to do is pass it an action. An action is a method that returns void, so it can't return a value, and we're going to give it the input argument, which is the value of this result object, to execute our tap function. So let's give it the name of action, for example, and we're going to say if the result is a success result, then you can execute whatever is the action that you want, and I'll give you the result value. Otherwise, I'm just going to return a result instance and you can't do anything. Now, how do we use this in our command handler? Well, I can say tap, and then I can access the invitation instance on the result object, and I can call my invitation repository add method and pass it the invitation object. What's interesting here is that the invitation add method already matches the signature that I'm expecting in the tap function, so I can even do something like this, passing in a method group for what I want to invoke. So let's get rid of this step here. Then the next side effect that we want to trigger is the unit of work save changes call, which is going to persist these changes in our database. I need another overload for the tap method, only this time the action is going to be asynchronous, but you can't have an asynchronous action because the return type is void. So what you'll have to do is add a function which takes in the value or nothing and returns a task. So we're just going to define a function that is going to return a task, and let's just invoke it here. So await this function. I'm going to change the return type to be async and a task of the result of the in. And if everything checks out, and I believe it does, then this function is complete. So how do we use it? Well, we say tap, and then we just define our function. Let's say unit of work, save changes async, and we pass it the cancellation token. Now what happens is our entire chain here becomes asynchronous, so we need to add an await statement in front so that it is actually awaited properly. And we handled the step here, saving the changes in the database. The last step is also a side effect. This one is sending an invitation email to the member for this gathering. This also fits something that we would pass to the tap method. Now notice that we need to pass in a member and a gathering instance. Let's say we can get these from the invitation. So I'm going to add another overload for the tap method, and I'm doing this because we need to define the extension method on a task of result of the in, because we moved our railway from synchronous to the asynchronous version. Now this isn't a result, it's a result task, and we obtain a result by saying await result task. So this is our result of the in, and I'm going to define our function to accept the in argument and return a task so that I can use it to take the invitation object and pass it to the email service somehow. So this is going to be function of result value, and if I go back to my command handler, I can say tap, and I can take the invitation object, and I can say email service, send the invitation sent email, and we need to pass it the member, the gathering, and the cancellation token. Ideally, I would pull these from the invitation object, so invitation member, invitation gathering, and I already have the cancellation token here. So this would kind of satisfy my method. Now the problem is I don't have the member or the gathering on the invitation instance. How do we get the invitation instance? Well, it's returned in this method here, send invitation, and if I take a look at the constructor, it's already accepting a member and a gathering instance. So I'm just going to define two more properties, which are going to be my gathering and my member, and then I'll be able to pass them to the email service. So member and gathering, so get private set, and of course we need to set these from the constructor, so member and gathering. And if I go back to my send invitation command handler, this is now working. So I can get rid of this here, and I just need to return a success result if this all succeeds, but I already have a function chain here which is going to return result anyway if this gets to the end. So I can just take all of this and return it directly from this method. And what I also like to do is just convert this into an expression body to make it even more concise. Let me paste in the old version of the handle method, which we had at the start of the video, and let's try to compare how this version, using imperative style of coding, looks like versus this one, which uses the railway-oriented approach and functional programming. The first obvious difference is the functional version is much shorter. It's about 10 lines long, whereas the imperative version is a solid 30-something lines long. As far as readability is concerned, I know most of you are going to say that this version is less readable, but I do believe there's also a learning curve to working with the functional style of writing code. I'm just going to remind you that you're probably writing your LINQ queries like this with the functional approach, and I'm sure you don't have a problem reading that, so why would this be any different? Railway-oriented programming can be a really powerful way to design your applications. If you want an introduction to the subject, I recommend that you watch this video here. Also, make sure to smash that like button, and until next time, stay awesome.